Welcome back from an ad break. So now let's just jump into our first concept. So we said we're going to be looking at density, mass, and volume. So you're going to be looking at these three things individually. So those, the density, the mass, and also the volume, those are physical quantities. So what is a physical quantity? How do we define it as? So we define a physical quantity as a physical property of matter that can be quantified by measurement. So all the physical quantities, they can be quantified by measurement. So what do I mean by that? So a physical quantity can be expressed as numbers, for example, mass, volume, and length. We know that when we're talking about mass as a physical quantity, we can express that particular physical quantity as a number to say that the mass of this particular object is 3 kgs. The mass of this particular object is 10 kg. Whereas when we are looking at volume, we can also express the volume in terms of numbers to say that we're going to buy 2 liters of Coke. So that is basically volume of a liquid. And then when we're talking about the length can also be expressed in terms of numbers to say that from this particular point to this particular point, it's 10 meters. Also the distance between point A and point B, it is 3 meters. So we can express all these physical quantities in terms of numbers. So then what you're going to be doing now is to look at them individually, starting with the mass, going to the volume, and also lastly going to the length, seeing how different are they. So to start, we're looking at mass. So what is mass and what does it tell us? So mass, it tells us how much matter an object or a body has, or how much matter or an object we have, right? And then the mass of an object or a substance tells us how much matter it consists of. So the mass of an object or the mass of a substance tells us how much matter it consists of. And then also, the greater the mass of an object, the more matter it contains. So if a substance has a greater mass, it means it contains a lot of matter. Right. We know that mass, it needs to be measured in kilograms. So the SI unit for mass is kilograms or kg as a unit. So when we measure the mass of a small object or small amounts of matter, we often use grams. So we use grams when you want to measure something that is very small, or we can even use milligrams if that substance is even smaller. So that means when we are looking, or when you're talking about 1 kilogram, that is equivalent to 1,000 grams. So 1 kg, as we have said, that is going to be equals to 1,000 grams, G. And then 1 gram, it is the same as 1,000 milligrams. So when we're talking about 1 G, that is going to be equals to 1,000 milligrams. Right? So those are our SI units and how we measure, or we can also even try to convert one from one unit into the other. For instance, if you want to convert the 2 kgs into grams, you know that if 1 kg is 1,000 kilograms, then 2 kg must be 2,000 grams. So if 1 kg is equals to 1,000 grams, then 2 kg must be 2,000 grams. Now, can you then guess how many milligrams we have in a kilogram? So the milligrams that we have in a kilogram, it is 1 million. So we have 1 million milligrams in a kilogram. Right. Moving right along. When we're talking about mass again, we can just take a practical example here to say, if we have a gold bar that has twice the mass of another gold bar, so we have 2 gold bars, one has twice the mass as the other one, then that means it contains twice as many gold atoms. So the one that is 2 times the mass of the other one will contain twice as many gold atoms within it, right? Then again, the mass of an object stays the same no matter where it is. So if you have this particular mass of this object, if you have 10 kgs of something, it is going to remain 10 kg wherever you are. You can go to the moon, you can go to the next planet, you can go wherever. The mass of that particular object will remain the same. Now, it is going to remain the same unless you cut a piece of it, because now once you cut a piece of it, it means you have removed certain atoms, you have removed something from that particular mass. So that means it is then going to change. So then, the same gold bar will have the same number of gold atoms, whether it is here in Gauteng, or it's in Bloemfontein, or it's even in London, or maybe even the moon. So we can take the very same gold bar and move across the country, or even go to as far as the moon. Then that gold bar will still contain the same mass, will still have the same mass. So then that tells us that the mass will always remain constant, or the mass will always remain the same. Remember, unless a piece of it is cut off. Now, what about volume now? We've discussed mass, now let's discuss volume. What about volume? So volume, that is now the amount of space that an object occupies, and then we're saying that whatever the amount that an object occupies, that space is called, or that object will said to be having a certain volume. So volume is measured in liters or in cubic meters. And how do we then calculate it? We calculate it by multiplying the length, the width, and the height of an object. So we need to use 3 dimensions when we are calculating volume. As we have on this picture on the side, we're going to say 10 multiplied by 10 and multiplied by 10. Remember that all of these are quantities. They can be expressed in terms of numbers. The length in terms of numbers, the width in terms of numbers, and also the height in terms of numbers. It just so happens that all of these ones here, they are 10 centimeters each. So for us to be able to calculate the volume, we're going to say V for volume is equals to length multiplied by the width and multiplied by the height. So we're going to multiply 10 by 10 by 10 to get the volume of this particular cube that we have here. Now, a liter is the space inside a cube that is 10 centimeter wide, 10 centimeter long, and 10 centimeters deep. So when you're talking about 1 liter, we're talking about the space inside that particular cube, and that space must have 10 centimeters in terms of the width. It must have 10 centimeters in terms of the length, and then also must have 10 centimeters, that's in terms of the height. And remember, to calculate the volume, you simply multiply 10, 10, and 10 to get the volume. And remember again, the units of this volume will be in liters or in cubic meters. So that means when we are given the dimensions in centimeters, we must be able to convert them into meters because the SI unit for volume is cubic meters or in liters. Then, furthermore on volume, when we measure small amounts of volumes, we use milliliters as the volume unit. Remember, when we are measuring small quantities of a certain substance, we can't use liters because it's too small. Right? So let's say you are measuring 2 drops of water. We can't say we're going to be using units of liters because those 2 drops of water, they are extremely small. We need to be using something that is close to those 2 drops of water. In this case, we're going to be using milliliters. And we should know that when we have 1,000 milliliters, that is the same as 1 liter. So 1,000 milliliters is going to be equals to 1 liter. Now, we said you're going to be able to use the formula of density is equals to mass over volume. Then what is density then? So density, it is a measure of how much mass of a material fits into a given volume. So that's density. Now we say density, it is the ratio of mass to volume, and then we can write the mathematical relationship to show this ratio as follows. We're saying that density is equals to mass over volume. So for us to be able to calculate density, we're going to be using this mathematical relationship to calculate either the density or the mass or the volume depending on what we are given. Right. If we have 2 materials with the same volume, the material with a higher mass, very important to note, the material with a higher mass will be more dense. It will have a higher or a bigger density. So the material that has more mass is going to be more dense. That is to say that it will have a bigger density than the other one that has less mass. We can think of density as the lightness or the heaviness of an object of the same size. So when we have 2 objects of the same size, the one that is more heavier is said to be having more density than the other one. So lastly about density, a substance that is described as dense will feel heavy. So that means when we have 2 substances, the one with more mass obviously is going to be heavy. So that means that substance is going to be described as having or as being more dense. right? So then learners, before we move on to our next concept, we're just going to quickly go for a short break and I'll see you just after this.